The composition of functions is another topic that you've probably seen in your earlier algebra courses. Here's the definition. If f is a function from a set A to a set B, and g is a function from a set B to a set C, then the composite function, which we write as g with a little circle f here, we see that's, say it's g composed with f, is a function from a set A to a set C defined by g composed with f is g of f of x for all x in the set A. So to understand this, it's best to look at an example. Suppose I have the set of numbers 1, 2, 3, and 4, and I'll call that set A. And then I have the set of numbers 5, 6, 7, and 8. I'll call that the set B. And then I have the numbers 9, 10, 11, and 12, and I'll call that the set C. And then I'll define a function f that maps 1 to 5, 2 to 7, 3 to 6, and 4 to 8. And then I'll define a function g that maps 5 to 10, 6 to 9, 7 to 11, and 8 to 12. And now let's ask, what is g composed with f of, and we'll pick a specific number here. How about of 1? So g composed with f, we write like this, g circle f of 1. Okay, now what does this do? Well, g composed with f brings something in A to something in C. So you can think of it as taking something in the set A and bringing it directly to something in the set C. That's what g composed with f would do. So g composed with f of 1, we can rewrite this as g of f of 1 using the definition. So this is g of f of 1. And now this would be the same thing as g of, well, what is f of 1? F of 1 is 5. So this is the same thing as g of 5. And what's g of 5? Well, here's the function g right here, and 5 is mapped to 10. So g of 5 is 10, and that tells us that g composed with f of 1 is 10. Now notice that this 1 here is in the set A, and that f of 1 is in the set B, and f of 1 is 5, so that's still in the set B, and 10 is in the set C. So what this did was it took 1 and mapped it to 10. This was something in the set A mapped directly to something in the set C. Let's look at another example. Suppose I have a function f which goes from the real numbers to the real numbers given by f of x equals 5x plus 1. And then I have a function g which also goes from real numbers to real numbers given by g of x equals x squared minus 2. All right, let's calculate a few things here. Let's first start by trying to find g composed with f of 3. What would that look like? Okay, so this is going to be g of f of 3, just using this definition up here. And this is going to be g of, okay, f of 3. Well, f of x is 5x plus 1, so f of 3 will be 5 times 3 plus 1. This is 5 times 3 plus 1. Okay. That's easy to calculate. 5 times 3 is 15, plus 1 is 16. And what's g of 16? Well, it's going to be 16 squared minus 2. And 16 squared, that's 256 minus 2. And so we get 254. Okay, well, what if I wanted to get a general formula for g composed with f? In other words, what if I didn't put in a specific number, I just left it as x? Well, I can do that in this case. I can say then that g of f of x is what I'm actually trying to compute. And that's g of, I can just plug in the formula for f of x. That would be 5x plus 1. And now g of 5x plus 1. Okay. So g of x is x squared minus 2. So g of 5x plus 1 is going to be the quantity 5x plus 1 squared minus 2. Just taking whatever's in here and replacing it with the x that's in the formula. And now I can multiply this out. So this is going to be 25x squared. And then I'm going to get 5x and 5x. That's going to be plus 10x. And then plus 1 minus 2. And I can do one more simplification. I get 25x squared plus 10x. And then I have a 1 minus 2. That's going to be minus 1. Let's use this formula to see if we do indeed get 254 when we do g composed with f of 3. So it should work. Let's just double check. So this would be 25 3 squared plus 10 times 3 minus 1. Okay, 3 squared is 9. So this is going to be 25 times 9 plus 30 minus 1. And if you do this on a calculator, or if you do the arithmetic, you do indeed get 254. So the formula works. No big surprise there.